column installation in the S7 Highway Administration Office took an impressive 10 minutes per column, showcasing the speed and efficiency of Pecco's bolted connections in precast construction, minimizing on-site labor requirements. The project achieved efficiency with only 3 workers needed on-site. The absence of on-site precast element storage, coupled with Pecco's connections, saved 60% of crane time. This streamlined construction logistics, reducing delays and enhancing overall efficiency. Eliminating on-site precast storage streamlined construction logistics, ensuring just-in-time delivery and minimizing clutter, contributing to a more organized and efficient construction process. Ample on-site space enhances safety, reducing potential hazards and congestion. The construction process was unaffected by weather conditions, ensuring a seamless workflow and eliminating delays typically associated with adverse weather, enhancing project efficiency. The high-quality connection system enhances precast building efficiency and structural integrity. The project was finalized in 12 days by only 8 workers. At site efficiency reduces the overall construction time. The manufacturing process of cross-laminated timber, CLT, by Kioi Construction involves several precise steps to ensure the production of high-quality and structurally sound panels. It begins with the careful selection of responsibly sourced timber. The chosen wood is then processed into boards, which are subsequently kiln-dried to optimize moisture content. The dried boards are then arranged in layers with alternating orientations, adhered together using environmentally friendly structural adhesives. The resulting assembly undergoes pressing and curing, creating a solid and dimensionally stable CLT panel. Kioi Construction's commitment to quality control and sustainable practices throughout each stage of the manufacturing process ensures that their CLT panels meet stringent standards, providing a durable, versatile, and eco-friendly solution for modern construction projects. At its core, CLT is composed of multiple layers of timber boards stacked perpendicular to each other. These layers are then glued and pressed together to form solid panels. The cross-laminated arrangement provides dimensional stability and remarkable strength, making CLT an ideal candidate for a variety of construction applications. One of the primary advantages of CLT construction is its positive environmental impact. Timber, the primary material in CLT, is a renewable resource that sequesters carbon throughout its growth. Harvesting and using wood sustainably contribute to the reduction of carbon emissions in comparison to more carbon-intensive materials like concrete and steel. Additionally, the manufacturing process of CLT often requires less energy than traditional materials, further enhancing its eco-friendly profile. The versatility of CLT extends to its application in both residential and commercial construction. CLT panels can be customized to meet specific design requirements, offering architects and builders flexibility in realizing their visions. Whether used for walls, floors, or roofs, CLT's adaptability allows for diverse architectural styles and construction projects. The speed and efficiency of construction with CLT panels also contribute to its popularity, making it a preferred choice for projects with tight timelines. Structural performance is a key strength of CLT construction. The cross-laminated configuration results in panels with high load-bearing capacity and dimensional stability. This enables the construction of tall buildings and large structures, showcasing CLT as a viable alternative to traditional materials. The strength and durability of CLT have been tested and proven in various applications, demonstrating its reliability as a structural material. In addition to standalone use, CLT is often integrated into hybrid construction systems, combining its strengths with other materials like steel and concrete. This hybrid approach allows for even greater design flexibility and structural optimization. The combination of CLT with other materials enhances the overall performance of a building, showcasing the adaptability of CLT to diverse construction needs. Geofoam Construction, a key player in the construction industry, has been at the forefront of promoting and implementing CLT construction. Their commitment to sustainable building practices aligns with the eco-friendly nature of CLT. Geofoam Construction's expertise in structural engineering and construction management has played a crucial role in advancing the use of CLT in various projects, from residential complexes to commercial buildings. Geofoam Construction has demonstrated the versatility and reliability of CLT construction. The manufacturing process of CLT is a critical aspect that determines the quality and performance of the final product. Geofoam Construction, like other industry leaders, follows a process that begins with the selection of responsibly sourced timber. The timber is then processed into boards and subjected to a kiln drying process to achieve optimal moisture content. The dried boards are arranged in the characteristic cross-laminated configuration and bonded with adhesives. The resulting panels undergo pressing and curing, creating a robust and stable building material.
The prefabricated sections, including columns, beams, rafters, purlins, and girts, were trucked to the Matakana site. These components were quickly assembled on site, ensuring precise alignment and robust construction. For the rural installation with a mezzanine covering a 12 meters by 9 meters area, the project integrated 89 millimeters and 150 millimeters roll-formed steel framing. This structural system facilitated the swift assembly of columns, rafters, purlins, and girts. The project utilized a combination of 89 millimeters and 150 millimeters roll-formed steel framing, chosen for its robustness and efficiency in construction. These framing elements, part of the XCA-LIBR system, were manufactured off-site by roll-forming services and delivered to the Matakana site for assembly. Additionally, Central Steel Framing, CSF, manufactured a steel staircase specifically tailored for the project's requirements, ensuring seamless integration with the shed's structure. This approach not only expedited installation, but also maintained high precision in aligning columns, rafters, purlins, and girts. All sections, including columns, rafters, purlins, girts, and the steel staircase, were fabricated within a swift 3-day timeframe. The project featured a floating mezzanine measuring 4.45 meters by 6 meters, elevated to achieve a ground clearance of 2.2 meters. This design maximized vertical space within the 12 meters by 9 meters rural shed, offering ample room for storing boats, classic cars, and other equipment. The mezzanine's structural support was provided by CSF mezzanine supports, ensuring stability and safety. Before setting the wall panel, apply a continuous bead of silicone caulk to seal joints. Use pre-drilled holes for an eye bolt, clevis pin, and cotter pin setup, ensuring rated pin setup and safety measures. Use appropriate construction equipment to lower the first wall panel end first. Ensure the panel is centered on the floor bay for proper alignment. Carefully position the panel according to the marked locations. Double-check the panel's placement to avoid alignment issues later. Securing panels as each panel is set, make sure it is plumb, vertically level. Brace the panel securely to maintain its position. Temporarily tack each panel at the top and bottom using nails or screws. This tacking is temporary. Final anchoring will be done after all panels are set and aligned. Tight connections ensure that all walls are tight to each other, as even a 1/8 inch gap can cause cumulative alignment issues over the length of the project. Use clamps to hold panels tightly together until they are tacked in place. Use a sledgehammer and clamp technique to ensure a tight fit between panels. Check that the sill plate is tight to the interior mark or that wall sheathing is tight against the edge of the floor system. Adjustments: if panels are slightly short, use provided plywood shims to increase panel width and realign the layout. If panels extend beyond the desired mark, start setting panels in the reverse direction to correct alignment issues, assuming floor and foundation dimensions are accurate. Temporary bracing: once the panel is in the correct position and plumb, secure it with temporary bracing to hold it steady. By meticulously following these steps, you can ensure the precise and secure installation of each wall panel, leading to a structurally sound and well-aligned building. Setting last panel finish with a panel that has a large opening, e.g. door, to provide handholds for tightening. Top plate connection: secure the top corners of the walls using timber lock screws as specified in the construction plans. Panel-to-panel connection: connect vertical joints using provided timber lock screws and a nailer plate, ensuring a secure and tight fit. The emergency repair and reconstruction of U.S. Highway 36, US 36 in Colorado, stands as a testament to innovative engineering and swift response in the face of infrastructure challenges. In July 2019, a critical section of US 36 suffered a catastrophic failure, resulting in the closure of the eastbound lanes near Wadsworth and Church Ranch Boulevards. The Colorado Department of Transportation, CDOT, faced an urgent need to restore this vital commuter artery, which connects Boulder and Denver and serves over 150,000 daily commuters. To meet the aggressive timeline for reopening, CDOT and Kremer North America, the contractor awarded the project, turned to Insulfoam's geofoam technology. Geofoam, an expanded polystyrene material known for its lightweight yet durable properties, emerged as the ideal solution. Unlike conventional soil-based methods that require time-consuming stabilization and compaction, geofoam could be quickly fabricated and installed. This approach minimized construction time and disruption, essential for a thoroughfare of such significance. Insulfoam mobilized 6 manufacturing plants across the United States to produce over 6,100 blocks of geofoam, totaling approximately 7.9 million board feet of material. This massive effort ensured that CDOT's stringent requirements for strength, stability, and rapid installation were met. Each block of geofoam was custom-made to fit precise specifications, facilitating efficient placement and minimizing labor-intensive processes.
The first step in building a wooden carport is marking the location where the structure will be erected. Carefully measure and mark the area, ensuring that it is large enough to accommodate your vehicles. Use stakes and string to outline the perimeter of the carport, providing a clear guide for the subsequent construction steps. Establishing a durable foundation is paramount to ensure the stability and longevity of your wooden carport. Begin by excavating holes for the wooden posts, paying attention to depth and width. Adequate dimensions are essential for providing robust support. Once the holes are prepared, carefully pour concrete into each excavation, enveloping the posts thoroughly. Precision in alignment and leveling is crucial during the pouring process. Allow the concrete to set and cure comprehensively, adhering to recommended timeframes, usually 24 to 48 hours, before advancing to subsequent construction phases. Post-preparation is a critical phase in building a wooden carport, ensuring the durability and longevity of the structure. Begin by measuring and cutting the wooden posts to the desired height, taking into account the specific requirements of your carport design. Once cut, treat the posts with a quality wood preservative to safeguard against decay and repel insects, particularly termites. This preservative treatment is instrumental in protecting the wood from environmental factors and enhancing its resistance to moisture and pests. Treated posts will serve as robust vertical supports, forming the fundamental framework of the carport. This meticulous preparation guarantees that your wooden posts remain sturdy and resilient, providing essential structural support for the entire carport. Begin by crafting bracing arms designed to reinforce the structure. Precision is key in this fabrication, ensuring that the arms align seamlessly with the posts. Subsequently, pre-drill holes in both the posts and the bracing arms. This preparatory step not only streamlines the assembly process, but also guarantees a secure and stable framework for the entire carport. The pre-drilled holes facilitate seamless attachment, fortifying the connections and contributing significantly to the overall stability and longevity of the carport structure. Securely install the prepared wooden posts into the concrete foundation, making sure they are plumb and properly aligned. Use a level to ensure accuracy. Once the posts are in place, fix them securely to the foundation to prevent any movement. In the sixth step, focus on installing the load-bearing beams atop the previously positioned posts. These beams shoulder the weight of the carport's roof, delivering crucial support. During installation, prioritize precision to ensure the beams align perfectly. Securely fasten the beams to the posts, emphasizing stability and strength. This step establishes a robust and durable foundation for the entire roof structure, guaranteeing that the carport can withstand external elements and provide reliable shelter for your vehicles. Attach the prefabricated bracing arms to the posts and beams, securing them with appropriate fasteners. The bracing arms add lateral stability to the carport, ensuring it can withstand various weather conditions and external forces. Moving to a critical phase, the eighth step involves installing the rafters onto the load-bearing beams, forming the fundamental framework for the carport's roof. Precision is paramount during this stage as you carefully space and secure the rafters. Ensuring even weight distribution is crucial for stability and longevity. Securely affix the rafters to the load-bearing beams, emphasizing structural integrity. Properly spaced and securely fixed rafters not only contribute to the overall strength of the carport, but also play a pivotal role in supporting the roofing material, creating a robust and reliable shelter for your vehicles. This step is instrumental in achieving a durable and resilient carport structure. Add diagonal braces between the posts and rafters to reinforce the structure further. Attach battens horizontally across the rafters to create the roof's framework. These battens will provide additional support for the roofing material and contribute to the overall strength and durability of the carport. In the 11th step, you have the option to enhance your carport by installing walls to enclose its sides, providing additional protection and security for your vehicles. Opt for weather-resistant materials for the walls, ensuring they can withstand exposure to various elements including rain, wind, and sunlight. The choice of materials, such as treated wood or durable siding, is crucial for the longevity and resilience of the walls. If privacy and accessibility are considerations, contemplate incorporating doors or openings strategically. This not only adds convenience for accessing stored items, but also contributes to the overall versatility of the carport. The walls serve not only as protective barriers, but also as customizable elements that can be tailored to your specific needs and preferences, enhancing the functionality and aesthetics of your carport. For the roof, consider installing canal tiles. These tiles are durable and provide effective water drainage. Secure the tiles to the battens using appropriate roofing screws or nails. Ensure that the tiles overlap correctly to create a watertight seal. Step back and admire the final result of your hard work. Your wooden carport is now a functional and aesthetically pleasing addition to your property. Test its durability and stability to ensure it meets your expectations and provides the protection your vehicles need. In Step 1, attach the edge insulation strip along the walls, extending into the screed. This crucial step prevents expansion in the flooring, eliminates sound bridges, and contributes to soundproofing. The self-adhesive feature streamlines the process, allowing easy direct application to the wall. In Step 2, achieve a flawless installation by seamlessly laying insulation boards on the substrate. Avoid cross joints for uniformity. Crucially, ensure the tab of the edge insulation strip is positioned above the insulation layer to maintain its effectiveness. Carefully attend to T-joints to prevent any disruption in the insulation's continuity. This approach guarantees an even and effective insulation foundation, optimizing the overall performance of the underfloor heating system and contributing to an energy-efficient and comfortable indoor environment. In Step 3, precision is key as you embark on installing the nub plate. Initiate the process by positioning the plate flush against a wall in one corner of the room, ensuring a seamless and snug fit. Take care to align the tab of the edge insulation strip above the nub plate, maintaining a consistent and effective insulation barrier. This meticulous alignment guarantees optimal thermal performance and prevents any thermal bridging issues. While securing the nub plate, strategically leave the location designated for the distribution box vacant. This strategic decision ensures an unobstructed space for the distribution box, facilitating a streamlined and efficient heating system. The distribution box, being a central component, requires accessibility for maintenance and adjustments, making this a critical aspect of the installation process. Furthermore, as you progress with the installation, pay attention to the transitions between different sections. Employ the use of tape to seamlessly connect and secure the transitions, creating a continuous and airtight barrier. This meticulous taping process ensures that there are no gaps or weak points in the underfloor insulation system, promoting uniform heat distribution and enhancing the overall energy efficiency of the heating setup. In Step 4, securely mount and connect the distributor, a pivotal element of the underfloor heating system. Ensure precise installation to facilitate efficient water circulation, allowing for balanced and uniform heat distribution throughout the entire flooring surface. Step 5 is a critical phase in the underfloor heating installation, focusing on the laying of the heating pipes. Start by guiding the angle bracket over the pipes, ensuring a secure fit that aligns with the desired layout of the heating system. The angle bracket serves as a supportive structure, maintaining the proper spacing and alignment of the pipes for optimal heat distribution. Once the pipes are positioned, the next step involves securing them to the leveling plate. Use staples and a system stapler to firmly affix the pipes to the plate. This process not only ensures stability, but also promotes an even distribution of the heating elements across the entire floor surface. The system stapler simplifies the task, providing a quick and efficient means of attachment. An advantage of this system is its adaptability to various laying patterns. Whether you opt for a traditional grid layout, a more intricate herringbone design, or any other pattern, the system accommodates these preferences. This flexibility allows customization based on the specific requirements and aesthetic preferences of the installation, ensuring that the underfloor heating system seamlessly integrates into the overall design of the space. For those seeking additional stability and precision in the pipe arrangement, an optional accessory comes into play: the diagonal fixation. This feature enhances the secure positioning of the pipes, particularly beneficial when incorporating diagonal patterns into the layout. The diagonal fixation mechanism provides extra support, preventing unintended movements and maintaining the integrity of the chosen design. To complete this step, it's essential to close the distribution cabinet. This action finalizes the connection of the underfloor heating system to the central distribution point, ensuring that the heated water flows efficiently through the network of pipes. The distribution cabinet plays a central role in regulating and controlling the circulation, allowing for adjustments and maintenance when needed. During the hot mop application, special attention is given to specific details, such as the installation of bowl and membrane in lead pipes. This targeted approach reinforces vulnerable areas, particularly around pipe penetrations, preventing potential leaks and enhancing the overall resilience of the roofing structure. To further fortify the roof, a reinforced 3D IES felt underlayment is laid carefully over the deck. This underlayment serves as an additional protective barrier, promoting longevity and weather resistance. In conjunction with this, a 26-gauge galvanized metal valley is strategically placed to facilitate proper water drainage, preventing water accumulation and potential damage. In the hot mop installation, the inclusion of vacuum metal over 30 pounds felt underlayment adds an extra layer of durability and strength. This metal layer enhances the overall structural integrity, ensuring the roofing system can withstand various environmental conditions. In the final stages of the installation, the team marks and installs hip and ridge metal, along with birdstop metal. Foam and toe screws are strategically placed in the first line of tiles, ensuring a secure and stable foundation. Step 1 of the process, bending onto a mold, is a crucial stage where the raw material transforms into the desired shape. The selected high-quality wood undergoes preparation to enhance its flexibility and make it more receptive to shaping. This typically involves steaming or soaking the wood to soften its fibers, making it pliable and easier to manipulate without compromising its structural integrity. Craftsmen then carefully position the prepared wood onto a custom-made mold specifically designed to match the curvature required for the railing. These molds are crafted with precision, taking into account the exact specifications of the project. Whether it's a gentle curve or a more complex design, the mold serves as a guide for shaping the wood to perfection. Using clamps, straps, or other securing mechanisms, the wood is gently coerced into conforming to the shape of the mold. Step 2 of the process involves fixing the curved wood railing onto a transport mold, which plays a crucial role in maintaining the shape and integrity of the railing during transportation. Craftsmen carefully position the curved wood railing onto the transport mold, aligning it precisely to match the curvature of the mold. This ensures a snug and secure fit, minimizing any potential movement or shifting during transit. Various securing mechanisms, such as clamps, straps, or fasteners, are used to firmly hold the railing in place on the transport mold, preventing it from coming loose or sustaining damage during transportation. The transport mold is typically constructed from durable materials that can withstand the rigors of shipping, providing an extra layer of protection for the curved wood railing. Its design is optimized to distribute weight evenly and minimize stress on the wood, reducing the risk of warping or deformation during transit. Step 3 of the process involves bending the curved wood railing onto a specialized spiral stairs mold, tailored to accommodate the unique curvature of the staircase. This step is particularly intricate and requires precise craftsmanship to ensure that the railing seamlessly integrates with the spiral staircase's design. The spiral stairs mold is meticulously crafted with a specific radius, typically around 81 centimeters, 32 inches, to match the curvature of the staircase. This radius is carefully calculated to ensure a perfect fit and smooth transition between the railing and the staircase itself. Craftsmen begin by preparing the curved wood railing, ensuring that it is pliable and ready for shaping. Using the spiral stairs mold as a guide, they carefully position the wood onto the mold, aligning it to match the curvature of the staircase. This process requires a keen eye for detail and a steady hand to ensure that the railing conforms precisely to the contours of the mold. As with previous steps, securing mechanisms such as clamps or straps are used to hold the wood in place, ensuring that it maintains its shape throughout the bending process. Craftsmen may need to make minor adjustments and apply gradual pressure to achieve the desired curvature without causing any damage to the wood. Flood protection systems for homes and properties play a crucial role in safeguarding against the destructive forces of floods, offering not only security for homeowners, but also enhancing the value and longevity of the affected property. Historically, cities built along rivers like Dresden, Regensburg, or Passau have borne the brunt of flood damage, but modern urban planning regulations typically restrict new constructions to areas deemed not prone to flooding. However, even in these supposedly safe zones, factors like a high water table can elevate the risk of inundation during intense precipitation events. For prospective homeowners or those considering property investment in flood-prone areas, it's imperative to conduct thorough due diligence. Understanding the local municipality's flood protection measures, such as levee construction and floodplain management, is essential. While these measures provide a degree of protection against moderate flooding, they may prove insufficient in areas with a high water table, where floodwaters can infiltrate buildings through basements or ground-level entry points. In such cases, homeowners must take proactive steps to fortify their properties against flooding. Utilizing flood protection systems becomes paramount. One effective solution is the installation of waterproof barriers or floodgates, which can be deployed quickly when flood warnings are issued. These barriers act as temporary shields, preventing water ingress and minimizing damage to the property's structure and contents. Additionally, investing in water-resistant construction materials, such as wood concrete for basements, can provide an added layer of defense against rising water levels. By fortifying vulnerable areas of the property, homeowners can mitigate the risk of flood-related damage and minimize the financial and emotional toll of such disasters. The approach to clamping in the chuck involves carefully aligning the wooden workpiece within the jaws of the chuck on the lathe. It requires precise positioning to ensure a secure grip, preventing any movement or slippage during the turning process. Turning off bark involves using a lathe tool to remove the outer layer of bark from the wooden workpiece, enhancing its appearance. Deep drilling with AG 2840 mm involves securely mounting the drill on the lathe's guide unit. The tube system incorporates a 40 mm carbide insert for efficient material removal. Integrated dust extraction ensures a clean working environment by removing debris generated during the hollowing process. The assembly of the hollowing tool involves meticulously fitting together its components to create a seamless and reliable instrument. The position-adjustable support, located approximately 2 centimeters in front of the workpiece on the handrest base. The feed at the handwheel allows for precise adjustment of cutting depth and speed, influencing the outcome of the hollowing process. The tube smoothly moves along both plastic and steel rail guides, ensuring consistent and stable movement during the hollowing process. The adjustable depth stop prevents the hollowing tool from cutting too deeply, ensuring a uniform depth and a clean bottom surface inside the jug, enhancing its overall quality and appearance.